another area that was among your interests, one of the main interests, about somehow the randomness-like features that you can observe in mathematics and outside mathematics.
Well, suppose that we know what randomness means for graphs. Yeah. So we flip a coin if you consider just 0-1 sequences and it is 0 or 1, and on that way you get a random sequence. And similarly, it started with Erdős and Rényi to consider random graphs. And quasi-randomness is a very surprising concept based on some very surprising facts. Namely, there are a lot of different properties of random graphs. I don't want to give a list because it is not quite a finite list. And then it turned out that quite a lot of different properties of quasi-random graphs are glued together. So if you have a graph sequence which has one of these properties, then you have all the other 5 or 6, which is a very surprising thing. That even when you have a graph sequence which is absolutely not a random one, but you know one of these properties, then you know all the other 5 or 6.
So let's say a specific example, for instance, the 4 cycles. So,
not the first, but simplest definition for quasi-random graphs is that if you have a graph sequence where the number of edges, say with probability half, is about the same as in the random graph with probability 1/2, and you know that the number of C4s, the number of 4 cycles, is the same, approximately of course, so I will always give a precise formulation, as in the random graph, then these 2 properties imply a lot of other random-like property. So, for example, in a random graph, the edge distribution is uniform. If you take a not too small, if the edge density was 1/2, then if you take a not too small subset of the vertex set, then the edge density will be also 1/2 there. This is one important property of random graphs, but the same refers to the density of triangles, the density of Petersen graphs, or the density of any finite graph, that the distribution is quite uniform in the graph. And there are some other properties which are equivalent.
So who introduced this concept of quasi-random graphs?
Henry Thomasson, who had some papers where he proved the equivalence of certain random-like properties. And then let me give the right order, Fenchung and Ron Graham and Richard Wilson, they gave a precise definition of quasi-random graphs, and they gave 5 or 6 equivalent properties. Equivalent in the sense that if you have a graph sequence, then it's trivial. If you have one of these, then you have all the other. And with Simonovic, we gave a, 7th one. And
but that was very important because you were linking that to the Semerade
partition. To the Semerade irregularity partition, yes. And now I can speak about 7 or 8, I don't know, equivalent properties of graphs. And all random graphs have these properties, but this is, of course, a much larger class, because there are a lot of properties of random graphs, but quasi-random graphs do not have.
You can't recognize that a graph is random, but you can recognize if the number of 4 cycles is about right.
You cannot check all the properties of a random graph, and of course quasi-random graphs can be, from certain point of view, quite deterministic.
Mm-hmm.